let's talk a little bit about scientific notation. So a lot of times in science, the measurements that you make or are given involve very large or small numbers. So for example, a gram of hydrogen would contain this many, that's a big number, of hydrogen atoms. That's a huge number. It's very cumbersome. And a lot of times your numbers are really, really small numbers, so with a lot of zeros at the front. And inputting numbers like that, or even writing numbers like that, and putting them into your calculator would be very, very cumbersome. And we don't want to have to write all those zeros or punch all those zeros into our calculator, so we decided that we're going to use something called scientific notation. So scientific notation, so if we took that number and put it into scientific notation, it becomes this number, 6.02 times 10 to the 23rd hydrogen atoms. So by writing it into scientific notation, we actually don't end up having to write all of these zeros at the end of the number, and it makes it a lot easier to write. So how did I do that? How did I put this number, which by the way is in something called standard notation, how did I get it into scientific notation? Well, the first thing I did is I figured out where I would find the decimal in this number. So this number has a lot of commas, and we're going to assume there's a decimal at the end of the number. And then I moved that decimal all the way to here behind the first non-zero digit to get this number right here, 6.02. And then I dropped all the rest of the zeros off, because after all, isn't that the point of scientific notation, is to get rid of all those zeros that you don't want to write. And then I multiply that number by 10 raised to an exponent. So how do I figure out what that exponent is? Well, I just count how many spaces I moved the decimal. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and that's how I get the 23. So it becomes 6.02 times 10 raised to the power of 23. So here's your general rules for writing numbers in scientific notation. So if your decimal is moved to the left, like this, we moved our decimal from here to the left, then your power of 10 is going to be a positive number. That means you're increasing 10 by that number. So another example, here's another example. So we assume the decimal is at the end of the number because it's not in the number. We didn't give you a decimal. We are going to move this decimal 1, 2, 3, 4 spaces to the left. That makes this number 2.09, and then drop those two zeros because we moved the decimal past them, times 10 to the 1, 2, 3, 4, right? 10 to the 4, and we make that exponent positive. So really, we're taking this 2.09 and we're multiplying it by 10 raised to the power of 4, and that would give us this number. Now, what if the decimal is being moved to the right? So if you're moving the decimal certain number of spaces to the right, then your power of 10 is going to be a negative number. So here's our decimal. It's 0.000560, this number. So we're going to actually move this decimal 1, 2, 3, 4, 5 places to the right. And that means that our number becomes 5.60. Notice I dropped those zeros off because my decimal moved past them, but I kept that zero. And we moved it 1, 2, 3, 4, 5 spaces, and we make that a negative 5. Oh, sorry, that makes no sense. Times 10 to the negative 5. So our number, let me rewrite that so it's a little clearer, is 5.60 times 10 to the negative 5. So that number is equal to that. Sorry, that was just really messy, so I'm rewriting it. All right, let's practice a little bit. Oh, first I want you to notice a couple of things. I want you to notice that when we did that, when we wrote a number in scientific notation, that when we moved the decimal, we always put it right after the first non-zero digit. So I'll come back and I'll show you. When we moved the decimal from here, we always put it right behind the first non-zero digit in the number. And we did the same thing down here. When we moved the decimal from here, we didn't move it all the way to the end of the number, we moved it just past the first non-zero digit. And that's pretty standard for scientific notation. So this number right here, we assume there's a decimal here, so we're going to move the decimal to there, and that becomes 5 times 10 to the third. And in this number, we're going to move the decimal from here to here, and that becomes 5.0 times 10 to the negative third. Alright, and the other thing I wanted you to notice is that trailing or beginning zeros that the decimal moves past when you're writing it in scientific notation are dropped. So when we moved the decimal past these 3 zeros to get the decimal to here, we drop them and don't write them in the number. And then same thing over here. These zeros we move the decimal past, so we drop them and we don't write them. We leave the last zero though because the decimal didn't move past that zero. Also, zeros in the middle of a number, don't drop those. That doesn't make any sense. Alright, let's practice. So here's some practice problems. I want you to write these numbers in scientific notation. So pause this video and take a minute and see if you get the right answers. Okay, so hopefully you practiced, and let's see what you get. So if we're going to write this number in scientific notation, we'll assume there's a decimal at the end of the number, and we will move that decimal to just past the first non-zero digit. So we're going to get 1.897, drop those zeros because we moved the decimal past them, times 10 to the ninth. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, this one, if you move the decimal, you're going to move it to just past this 2, the first non-zero digit in the number. So you'll get 2.10, remember drop all of these zeros, but keep the last one, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, negative 8. This number right here, we assume the decimal is here, and we're going to move it all the way over to just past the 2. So we keep 2.5, drop all those zeros because we don't need them, because they're placeholders, times 10 to the, let's see, 3, 6, 9, 12, 14. And then the last one, we've got a lot of decimal places here to drop, or a lot of zeros to drop. We're going to move it to just past that 5. So it becomes 5.6400. Remember, you can only drop the decimals that you're, or the zeros at the beginning that you're moving the decimal past, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Negative 20. Alright, let's do a little more practice. This time I want you to take these numbers and expand them into standard notation. So pause the video and try it. Okay, hopefully you tried it. Let's see if you did it right. So we're going to take this number and we're going to expand it into a standard notation, meaning we're going to add the zeros back. Notice the negative 8. That means that this number is actually going to be, we're going to move that to the negative or to the left. So we're going to take that decimal and move it 8 spaces to the left. So you're going to get 0.000000451. So you took the decimal and you moved it 1, 2, 3, 4, 5, 6, 7, 8 spaces to the left because it was negative. The last one, that's a positive number, your exponent, so you're going to move the decimal to the right. You're going to take this number and expand it so that it's larger than 9.010 because you're multiplying by 10 to the 12th. That's a big number. So we're going to move this out, that decimal, 12 spaces. So you'll get 9, 0, 1, 0. So that's 3 spaces. 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can put your commas back into this number to make it look a little easier to read. All right. Let's talk about how we would input a number that's in scientific notation into your calculator. So there are a lot of different kinds of calculators. You want to make sure your calculator is a scientific calculator, and the button you want to make sure you look for in your scientific calculator is a button that either says EE on it, or you want to look for a button that says EXP. I don't know if I have an example of a calculator that has a button, an EXP button. I don't think that I do. But it'll be usually down here and it says EXP. So that's the button you're looking for, either an EE or an EXP button. Most of you probably have this calculator right here, which is a TI-84. Notice the EE button is right here. In fact, it's a second function, which means that you don't have a button for EE. It's a second function, so you'd have to push the second function and then this button to get an EE. So there you go. Okay, so you need that button in order to enter a number in scientific notation into your calculator easily. If you don't have that button, it's going to be a little bit more difficult, and you're going to have to come see me so I can explain to you how it is that you can put a number in scientific notation without that. Okay. So let's say we want to enter this number, 6.022 times 10 to the 23rd, into our calculator in scientific notation. So I'm going to go ahead and use my TI-84 to do this, and I'm going to do it first, and then I'll walk you through the steps as I do this. All right, so the first thing that you're going to want to do is you're going to want to enter this first part of the number into your calculator, so 6.02. Easy. Now, the second thing you're going to want to do is you're going to want to hit your exponent button. Now, remember, your EE or your EXP button, if it's a second function, you're going to have to hit second function first. So mine's a second function. I don't have an actual EE button. So I hit second function, and then what I get is this little E. And then the next thing you're going to want to do is enter in your exponent. So the exponent in this number is a 23, so I'm just going to hit 23. So there it is. I've entered 6.022 or 6.02 times 10 to the 23rd into my calculator. I want you to notice that at no point during this process did I ever hit the times button. So I never hit times and I never hit 10, ever. The reason why is because the EE button, or that EXP button if that's what you have, actually means times 10 to this, so I don't have to put times 10 into the calculator because that's what the EE button does for me. Now, be careful. I don't know why it is, but a lot of you want to go 6.02 times, and then you go 10, and then you hit EE, and then 23. What that gives you, don't do this. That's bad. What that does is it takes that number, multiplies it by 10, and then raises it again to the power of 10 to the 23rd. So you actually end up getting some crazy, crazy number, right? You end up getting a number that's way bigger in magnitude. So don't do that. You never need to hit times 10 to that because you're using the EE button, and the EE button does that for you. All right, so let's make a calculation. Let's say we want to, take two numbers in scientific notation and actually calculate them, or involve them in a calculation. So the way